Hello everyone and welcome back to the CATIA training series. In today's lesson, we will continue exploring transformation features toolbox and learn how to accurately move and rotate solid bodies using the translate and rotate commands. By the end of this lesson, you will understand all translation methods and the different rotation techniques available in CATIA. Let's get started.
I got this magic in my fingertips, designing dreams with every click. Shapes and wonders coming to life. With CATIA I cut through strife. In my mind the future's clear. No more doubts, no more fear. Crafting visions in 3D. CATIA's the key, don't you see? I can reach the sky so high. Build my dreams, no need to try. With every tool I sculpt my fate. CATIA helps me innovate.
Hello everyone. So far we have reviewed two main and essential toolboxes from the part environment. With the tools in the sketch-based features toolbox, we can create our sketches in 3D in various ways. With the tools in the dress-up features toolbox, we can style the generated volumes. Now we are studying the transformation features toolbox. With the tools in this toolbox, we perform various operations on existing volumes. This toolbox itself includes several sub-toolboxes and other tools. The first toolbox is named Transformation. This toolbar includes 4 distinct tools. These tools are used for translating, rotating, and symmetrizing a part. The first tool is named Translations. This tool is used to move volumes. Currently, I have a cube on the screen. The cube's width, length, and height are all 100 millimeters. One of the cube's corners is at the center of the coordinates. I click on the translation tool to open its settings window. Upon clicking the tool, a question text appears. The text asks if we really intend to move the part. If I click no, the text closes and the tool becomes inactive. So I click yes. The tool's settings window opens. This window has one section and currently 3 options. The first option is named Vector Definition. This is the main option of this tool. In front of it, there is a box with the symbol V. By default, inside this box, it says Distance Direction. Below them, you see 2 options with the same names. In front of each, there is a box. We must specify the extension and displacement value through these options. The software moves the body based on the given values. Now I click on the V icon. 2 other modes are displayed. The second mode is point to point. I select it. The names of the next 2 boxes change. Here I must introduce 2 points to the software. These points can be created beforehand. or I can use the vertices of the body itself. There is also a third solution. I right-click inside each option box and create a point. The third mode is Name Coordinate. I enable this mode. 4 options appear below it. The first 3 options are related to the XYZ coordinate values. There is another option that allows us to choose a specific coordinate axis other than the main axis. Note that we can define an infinite number of coordinate axes. I will teach the method of creating coordinate axes in the future. By entering a value in the box in front of the axis, we specify the displacement of the part. But how will the software move the part? The software moves any given point on the part to the specified size. For showing this, I create a point using the Measure Inertia tool at the 3 surfaces of the part. Every point on any surface has a color. I enter the number 200 in the box in front of the x-axis. I click OK. It is observed that the part has moved. Again, I create colored points on the same cube surfaces using the Measure Inertia tool. I activate the Ruler tool. The measurement tools in the toolbox will be explained in a separate lesson. I display the measurements on the screen. It is observed that all 3 points have been sheaved by 200 mm. Now let's examine the second tool named Rotation. I activate this tool. The settings window opens. Again, a question text appears. I close the text by pressing Yes. Like the previous tool, this tool also has only one section. The first option is named Definition Mode. Currently, it is set to Axis Angle. 2 options with the same names appear below. To perform a rotation, we need a rotation axis and a rotation angle value. The rotation axis can be a straight line or an edge of the existing volume. We enter the rotation angle value in the box next to the angle option. I select an edge of a cube. I set the rotation angle to 45 degrees. I switch to the top view mode. I click OK. You will see the shape rotate 45 degrees around the edge. I press the Ctrl+Z combination keys. I switch to the isometric view. I activate the command again. The second method is name access to elements. I activate it. Now three options appear below. The first option is Access. I right-click in the box next to it. In the drop-down menu, I select Z-axis. The second option is activated. Now I move the mouse over different parts of the cube. You will see the software accept points, lines, and surfaces. Note that if the software does not accept an element, it will display a no entry sign. Also, note that the selection of elements should be in harmony with the selected axis. Now I select a corner of the first element on a cube. In the second element section, I choose another suitable corner. I click OK. The shape rotates in the correct direction. Now let's check the third option called 3 points. This option is a little complex. I'll try to explain this option in the simplest way for you. Here we need to introduce 3 points to the software. What conditions should these 3 points meet and how does the software use them? First, the 3 points should not be on the same line. The first point is the origin point. The third point is the destination. Here the first point moves and reaches the third point. So how does it do this? The second point or pinpoint is the center of rotation. I've created a cube with colored faces, additional lines, and rounded edges. First, I'll show you the rotation on a surface. I will name this page the host page. Imagine two initial points along a vertical edge and the third point along the horizontal axis of the first point. I'll show you the shape's rotation in the appropriate view. The software moves the moving line between the first and the second points so that it lies on the plane or is parallel to it. Now I place the third point along the horizontal axis of the second point. you can see the cube's rotated shape. This method allows you to set the axis and rotation angle as desired. It is used for creating complex rotations that cannot be achieved with other methods. Understanding how to use this option in selecting appropriate points is essential. Very well, today's lesson is over here. I hope you paid attention. Please watch the lesson carefully. Practice with me again in the second round. Good luck. See you until the next lesson.
Let's build the future.